Yeah. So that I'll be able to help you.
This
Yeah.
conference will now be recorded.
X X is it? X is it? Is that your question? Huh. Uh-huh. Uh-huh. Yeah. So this is positive edge, right? And output you have given #5. So that output skew that will go for 5 nanoseconds after the positive detected. Yeah, because at next position, oh right, it should actually continue further till uh-huh. Yeah. Uh-huh. That is valid. Valid here. Okay. Yeah. Can you show me the code? Yeah. Please open it. Yeah. Can you join to the session so that other people can also see? Uh, yeah. So that I'll be able to help you through that. Is it possible for you? Is your network good enough? So while we debug your issue, other people can also understand. Mute your system, otherwise it will create it. Yeah, I'll make you presenter. Ashok Kumar, right? So show me your driving first. Output is #5 for all of these. And default output is 2. Okay, so wherever you're not given, there only default value will be given. So output Q is #5. Let's go to driving and BFM. Yeah, that's fine. Uh, this is at, you're getting the value. Then waiting for this. Okay, scroll down. What is finished? I didn't understand. Huh. No, no. Can you explain why it is different? Uh-huh. Count 5. Hmm. Yeah, but without logic, this will work, right? No. See, as long as there is next transaction in mailbox, it will go on. No matter what is the number of transactions. Yeah, it has to be, right? No, not required. See, generator, for example, your generator has generated 10 transactions. 5 writes, 5 reads. It will generate all 10 transactions in 0 time and put all of them in mailbox. N writes. 2n. 2n, right? N writes and then n reads. Okay, only writes. Then, okay, n. Huh. Yeah.
That time if we increment by 2.
Okay. Okay. So you're writing this particular finish only for if you're doing single write or single read, or just write or just read.
That's right.
Okay. Show me the functionality then.
It will, like here
Yeah, that's fine. I understood. Show me the functionality. For one, right? You have SMT finish dot put 2 star common mem count. Can you explain line number 40? Yeah.
like the total number of count we want to finish us. If we count, we have default given the count right.
Mhm.
We need to finish.
When 5 writes are done. If you're doing just
Only
right.
one right and read.
Okay.
But we are expecting the condition over there it should be 10.
It's one right. No, I'm reading one right. So if you're doing just one right, count is one. Count will be one right. So only one transaction should be done.
But it won't, the finish not be occurred. According to our what we
That logic, top model logic.
So to get that, I'm making the count will be twice of the amount. And directly match.
Okay, okay.
Like next
Yeah, got it. This logic will be done only for single writes or single reads. If it is right and read together, then it will continue as it is, right?
Same way.
Line number 55 onwards, same logic should be used, right? Otherwise, you are multiplying the count by 2. Yeah, okay, I got that. But now, scroll up. So this finish, I think it should be done after line number 32. 32. 33, sorry, 33. Because finish itself is not consuming any time, and you are incrementing the count before you are resetting. Okay, that being done, you are putting back the semaphore. Okay, so show me the. Okay, can you execute the code again? Save and execute again. Let's see what changes happen. Yeah, all of these warnings are for randomized. If you just add assert in front of it, those will vanish for everyone.
Even though I'm given statement for me,
Valid is X.
I didn't go that for that.
Okay.
But the value center.
Show me waveform. We're still getting just till this much. At posage, exactly it is changing when it should change after 5 times. 5 time steps.
The thing is like the data is not available in any of the process, but the memory I was showing memory is the write is happening. Same way the read is also happening from my memory.
Yeah, because write read equal to 0 at a posage, right? That's why it's reading.
How
it is resetting at posage now. It is taking it as a transaction. You're getting it at this point. See, your first write is happening, and write is going down. Write enable is going down exactly at posage when it should have reached till negative. So it's going down at posage. So it's taking it as a read transaction. For next posage, you see not this one, next one. There is write enable equal to 0. Write read equal to 0. So it's taking it as read, and at the end of that posage, you're getting the data. Same thing is happening here. Write enable going up. And valid. Yeah, and valid is also somehow valid is also high at that point. It's not. Yeah, please mute yourself. Yeah. See, valid is also going high somehow. It is, see, valid is going high, and that's when ready is also high, and you are getting the read data. When ready is going high, you are getting the read data. The same thing is happening every read. Next posage. Yeah.
The data is 0,
Mhm.
and here is somewhat like address is also 0, even though it is performing operation.
Address is 2.
Like
Valid is 1.
And negative is only the address is 2, right?
No, go to your clocking block. Yeah, so when you give when you give default input as 0 and default output as 5, like somehow taking the tool is somehow taking the previous value when it should have taken the next one, right? Valid should have been 0 even if you see read equal to 1.
My point is the data is not available either in one of the possibilities.
It open waveform. It is available. This is data, right? At that posage, right before it changes to 0, data is available.
Exact process it is showing me 0.
Yeah, even before. No, listen. Even before we implemented clocking block, do you remember the time we had implemented generator BFM both? Data was getting read properly. the clocking block was required to monitor the transaction. So what happens is, even though data is changing at exactly the POSIX to 0, it doesn't matter. It has written at that moment. At POSIX of moment, it has written the previous data. And transaction will happen fine. If valid and ready are high, even though they are at that POSIX, valid is going 0 and ready is becoming high. This won't work for monitor. Monitor won't be able to do collect this transaction, but VFM will do the driving. So that's why you are getting read out of the data, out of the memory. And I'm not understanding why that thing is not continuing till next negate, because you have given hash 5. So I think we'll have to look into it properly. I mean, there are very less possibilities why this should happen. Maybe the way you have written some logic, I'll have to go through your code. You seem to have added extra logic. So can you send me the code? Send me the code. I'll go through it and get back to it next session. Yeah, you can start. Did anyone understand what is this issue? Anyone understand what is this issue? No? Okay. Okay, when we debug it, at that time I'll explain. So he's implementing clocking block for output skew of 5 times steps. I think that might be. Same thing was happening. It was not extending. Maybe there is some logic that is missing or something. We'll have a look at it. Okay, so we did basic fork join in last session, right? What are all the variations of fork join? And Verilog fork join, right? What is the difference? Does the functionality differ in what happens inside fork join? What differs? What happens inside fork join, not outside? Does functionality of any of these fork joins differ outside the fork join? No. Only outside the fork join, the functionality differs as to when the next statement will execute, right? Whether it will execute after all the processes are done in fork join, which is basic fork join, or whether it will be done after at least one, which consumes minimum time, is done. Then outside statement will execute, or outside statement will execute along with the inside processes. Right? Now, can you think of a scenario where we might require?
Ma'am, your screen is not visible.
Oh, right. Thank you. I didn't share. I forgot after that. Yeah. Is it visible now?
Yes, ma'am.
Yeah. So what we can do is, before you answer that, I'll tell you a concept. What we can do is, we can disable a fork. Meaning there are n number of processes in my fork. Once particular number of processes are done, right? Minimum, maybe minimum time consuming, or maybe a particular time consuming. Once that many processes are done, I should end rest of the processes. Rest of the processes written in fork join should not execute. Once a particular number of processes are done. Maybe not by number, maybe by time. Let's not go by number, because number will include counting number of processes and all. Let's not go into that. Once a particular time unit has occurred, right? What we need is, we need to exit fork. That means we do not want to execute or complete rest of the processes inside the fork join. Any or none or any of the variations. Once a particular time is done, I want to stop fork join. Okay. So System Verilog provides a construct for that. That is disable fork. Right. I'll tell you how to use that. Disable fork dot sv. So what we have, let's just have initial, begin, and just have displays, nothing else, right? Fork join. We have begin and process 1, 2y by 2p. We have 3 processes. Okay. In this process, I'm consuming hash 10 and then displaying process 1 done. 2y by p. Here I'm consuming 15 time steps and displaying process 2 done. Right. And if here I'm consuming, what can we say? Hash 5. And I'm displaying process 3 done. So as it is, how will it display? 5, then 10, then 15. So 3, 1, 2. Correct? In this order, it will get displayed. So what disable fork does is that I can decide a particular time. I don't want anything to execute after hash 12 is done. After 12 time steps, whatever are the remaining processes, I don't want them to execute. So I can include that disable fork as a separate process inside my fork join. Hash 12 disable fork. So what is happening here is, after it will first consume this much time and then it will disable fork. So whatever is left here won't get displayed. Whatever are the processes left. So what will happen outside fork? This will get displayed. Okay. What if I write this here? Tell me what will happen. This is fork join. Huh? What if I write this here? Which ones will not show? Tell me. Comment out line number 16 and let line number 18 be functional. Tell me which display won't show. Yeah. Nothing will show. Everything will execute. Writing this has no meaning. Why? Because we are using fork join variation. Under it, next statement after join will execute only after all the processes inside fork join are done. Got it? So next time you answer, think about it. Now let's see. This has no meaning. Yeah, it's outside the fork, right? Join, outside of the join. So this has no meaning. So when you are using fork join, disable fork after join does not have any meaning. If I want to actually end up, if I write it here without delay, what will happen? Yeah, none of the processes inside the fork join will execute. Why? Because line number 16 is treated as separate process in fork join. And since it is happening at 0 time, it will execute first. So even before you have started anything, you have disabled entire thing. So again, it's like not writing line number 3 to 17 at all. So again, this has no meaning. No meaning in coding. The same thing, no meaning in coding. So what has some significant meaning in the coding? You give some delay. So what that will make sure of is some processes will be disabled, whatever you want, whichever you want, after whatever time, number of time steps you want. Some processes will be disabled, some processes will execute completely. So hash 12 disable fork. Now let's execute this entire thing with all the disables, right? I'll uncomment each disable one by one. Okay. I see less number of people today. Your friend that was here, no, not your, the last person. Your friend that was here that day, he has not. Why? He is? He's online. Okay. Anand Maurya. Okay, Uday Prasad. You're Anand Maurya. Uday Prasad, are you not responding? Did you understand what we covered? Yeah.
Yes, ma'am.
Did you understand? Yeah. Okay. Disable fork. Your friend who comes, she's not here. Okay, she's also online. No, she's not. Okay. Okay. So let it be. Okay. Let's do it with run1.do. Sharan, he also generally attends offline, right? Okay. What did I do? Hash12, how come process 2 is displaying? Why you? Label. So that I'm specifically disabling port 1. Because it's displaying process 2 anyway. Yeah. So disable fork is not working inside fork join. When we actually give some labeling to the fork, then disable keyword works. Okay, disable F1. So with fork join, simple fork join, only giving some delay and then disable inside the fork join will work. So whatever time step after which you don't want something to execute, that time step you will give here. Are you clear about this? Any questions?
Now we can do it that even outside. After labeling.
Yeah, let's comment this out.
After labeling.
Yeah, outside also. Yes, yes. After labeling, we can do that. Let's see. This one, right? I think here fork will work, but we won't know if it is working or not because anyway all three processes will happen. So we'll try this disable fork with fork join any. As of now, we won't know even if we give this here, we won't know if it is working or not. Why? Because anyway all three will be done. So you will see that here, even if I'm writing disable fork, it has no meaning here. Everything will be executed, right? So let's see. Let's keep this and let's use line number 3 to 20. Let's name it F2, just in case if we execute all together. Comment this out. Okay, and make it any. And then use disable. Let's work on disable fork first. So what should be the functionality here? Yeah. So at what time it will come out and execute this? So how many processes will get displayed from fork? Just one. So let's see if that functionality is happening. If it doesn't work, we'll use F2. Yeah, it's working. So outside fork, that fork will work. Inside fork, labeling is required. Let me write that. Oh, what happened? How come? Why? Okay. Let's write that down. Disable fork. Right? Above works when you write yes. Without labeling, it won't work inside the fork. Without labeling, it will work outside the fork. And if I label it, that will also work outside the fork. Okay. So let me write that down. Above works when you write disable outside the fork. Inside fork, to make disable work, we need to label fork and disable that label. Wow, disable that label, right? So that's how. What is the spelling? I think it's label, not label. Yeah. So we need to label the fork and disable that label. So what happens here is with fork join any functionality, any one. So that will make sure that only one process will execute. So you observe the difference here when you are disabling the normal fork join. You can let multiple processes complete before you disable it. Even if you are giving that time step can include multiple processes being finished. But with fork join any, you can let only one process finish. Why? Because fork join any will start executing next only when one process. Now, if I still want some processes after this one process to execute, what can I do? No. Add some delay. That's it. Hash. Let's add 8. Now, what will happen? At 5, this will start executing, but I have given a delay. So within 8 time steps, whatever processes can finish, those will finish. Clear? Okay. So what we have here is, can you think of an example, think of a scenario in your memory test bench, right? Where you want to do just one of the two processes. If one is completed, the second shouldn't happen. It has something to do with handshaking. It can be replacement of one of the assertions. I have told you that this particular check can be done in assertions. So instead of assertions, you can write this logic using fork join. So think about a situation where you can use this. It's related to handshaking, one thing. Second thing, this logic, if you use join any, this can replace one of the assertions related to handshaking that I had explained. So there are two processes. If one happens, second shouldn't. Or if the other happens, first one shouldn't. What are these two processes? Yes? You were saying something? Okay. So if valid is raised, ready should be received within 3 clock cycles. Right? So how will you make sure those 3 clock cycles is fulfilled? You will be simply waiting for ready to be raised. So if you write the wait logic, you will be stuck at the same point. Till the time you receive ready. If ready never comes, you should be able to exit after a particular time. So one process will be waiting for ready, other process will be exiting after 3 clock cycles. Got it? Is it possible to replicate this scenario in separate module, not in entire memory test bench? Because once we are sending valid, ready is going to be raised the next clock cycle. So we'll never be able to see this. So standalone, this thing, is it possible to implement this scenario with clockage and everything? Only thing is DOT won't be there. We will be generating the valid and ready combination. Is it possible? Yes, it's possible, right? So let's do that. We'll call it request acknowledgement instead of valid ready. This is more of generalized handshake. Okay, request acknowledgement.sv. So what happens here is, first thing we want is clock, right? Bit clock, and let's also hash 5 clock equal to negative of clock. With this, I have to make sure I write some sort of finish logic. Begin end. So let's wait for 100 time steps. $finish. Now it's my responsibility to write some valid logic. Again, my responsibility to write some that is request logic and acknowledgement logic. Right. So let's have it look like a normal waveform that we observe in our test bench. So let's have a reset as well as request acknowledgement. Right. Reset is also there. So let's YYP. So we have reset equal to 1 and then repeat for 2 clock cycles. What? At the rate positive of the clock, right? And then make reset equal to 0 for rest of the code. So let's see, initial, begin, and you have at the rate negate of reset. When we see negate of reset, then only this should happen. Let's raise valid equal to 1. Again, request equal to 1. Let's raise request equal to 1. Now I want to see if I can get out of the fork join without receiving the acknowledgement. So I want to view the scenario where acknowledgement is not received. So I will not do anything here, or I will raise acknowledgement after 3 clock cycles. Okay, so repeat 4, right? At the rate. So that same logic can be used when acknowledgement actually received. So repeat 4 times at the rate postage of the clock. So once request, okay, that also YYP. This should be raised at postage only, right? Postage of clock. After negate of reset, next postage I should raise request. Then after 4 postages, I am making ACK equal to 1. This is the logic for stimulus. Now let's write logic for joining. Disable 4. Right? What is my first process? To spend just 3 clock cycles. Repeat 3 times. At not at any time. If acknowledgement equal to 1, right? Then begin and then repeat. Otherwise, you don't need to. I mean, it will just count first 3 clockages and come out of the fork join. We don't want that. We want to count clock cycles only when request is received. When request is received, then only you should count the clock cycles. So when request is 1, I'm repeating 3 times at the rate postage of the clock. If this ends first, what should happen? It should come out of the fork join and disable. So I will display here, or I can display here. $display acknowledgement not received. Okay, and here $display outside code. Okay, what is my second process? Just wait for acknowledgement. Generation of acknowledgement is here. That is generation of stimulus. Yeah. Simply wait here. Wait for acknowledgement equal. Again, this also can be done if valid is seen high. If request equal to 1, then wait for. Okay, I'll write it in beginning so that I can display something. Wait for acknowledgement equal to 1, and then $display acknowledgement received. Anyone has any question in the logic that I have written here? Do you want me to scroll up or down anywhere? Yeah, somewhere POSIX should be checked. Yeah, we need to check because this will happen only at POSIX, right? So let's check it here. In this, and here also we'll have to check the same.
And even though the process needs to start after the reset initial work.
Yeah, it's fine. At every POSIX it can look for it, but if you want to, if you want to, you can write a negate here. At negate of reset only this functionality should start. Otherwise it shouldn't. But this is just checking the signals, right? So even if it starts from first POSIX, that's fine. Yeah. It will start at 0 time. That's true. But this is not something that is generating stimulus. It is only receiving or checking the stimulus values. So it's fine. If that block was generating stimulus the way this one is, then it's required that you start it at reset, because in general normal functionality is after reset is gone down, then only you should start driving, right? So this can be written, but it is redundant. It won't matter. I'll remove it here. Is it clear what we've done here? Yeah. No. Which part you didn't understand? Yeah. This is if acknowledgement is not received. What will happen? It will check if request is high. Right. Yeah, we need to do something. If request is 1. No, we don't need to. See, if request is high, then we will start pending clock edges, right? Only 3 clock edges. And this will also start parallelly. When this starts, at that time only this will start. If acknowledgement is received, right? At the same time, this will start functioning. So if this catches, if this executes before 3 clock edges, this will be done. It will come out of join any, execute this statement, and end this. If we do not get here, we'll be stuck at this line. Nothing will happen further. We'll be waiting for acknowledgement to be received. Nothing will happen further. But if this gets completed first, if 3 clock cycles get completed first, we'll simply display that acknowledgement is not received. We will end this particular process and will come out of the join any, and we will disable code. So this wait, we will not be stuck at that anymore. Got it? So one of the two things should happen. We should at least be waiting for the acknowledgement and then ending the 4th join. Or if acknowledgement is not received, after 3 clock cycles, we should anyway end the 4th join. We should not wait for acknowledgement beyond 3 clock cycles. So what will happen here? What is the stimulus that I'm generating here? Yeah. Yes. Yeah. What will happen? Which condition will go through? First one or second one? Huh? Yeah. If request is 1, then only we should start wasting time. Oh, yeah. Wait. This is where we are waiting for acknowledgement. We can also wait here till the time this is received. We should not start wasting time. Yeah, tell me. Because this happened. If acknowledgement received before 3 clock cycles, it will get received here, and then this process will end, and then it will disable this one. There are 2 things happening. Either we should get acknowledgement, or 3 clock cycles should complete. These 2 things. Either when request is raised, either acknowledgement should be received before 3 clock cycles, or if 3 clock cycles complete first. If this happens, acknowledgement equal to 1 happens first, then it will disable this. 3 clock cycles won't be wasted. But if it doesn't happen before 3 clock cycles, this is time, right? Repeat at the position of the clock. This is time consumption. This time will finish first. Then we will display acknowledgement not received within time. You can say within time. That will be less confusing. Within expected time. Received before 3 clock edges. Got it? So when we see request equal to 1, we should start wasting time. And then display if we don't receive the acknowledgement. If we receive acknowledgement, this is happening parallelly. We will receive it here. Okay. If we receive acknowledgement, we will receive it here, and this display will happen, and that display is last line. After that, no time is getting consumed. So it will end this process and come to disable 4, and it will disable the 4. This will not happen. This will not finish. Understood? Any doubt? No question? Okay. Any questions? Understood? So let's execute this here. Request ack.sv, because we want to view the waveform, right? And not of the DOT. slash start. Whatever signals we are having here, all of those signals I want to view. Sim slash top slash start. Top is there, right? Yeah. Okay. So instead of run 1, we will do run dot. Dollar display syntax error, expecting this line number 44. Yeah. And after disable fork, we need to put a semicolon. It's directly out of the fork. Okay, let's view waveform. Wave is there, but I'm not able to see it. How? Yeah. It's which one? This one? It's yeah, it's disabled. It's only moving on. It's not going up or down. Okay, what I'll do is I'll simply resend again. Open this thing again. Request 4 clock cycles and then acknowledgement. So it should have disabled the fork. It's displaying this, but not this. What if we don't do this? Still not done. Outside fork only. We're missing something. Mhm. Yeah, that's where they should start, right? At POSIX, when they see request is high, this should start happening. Oh, wait begin. What is this wait begin? I had written if and begin, right? There is no begin for wait. Yeah, I think now it will work. And that POSIX should have been kept as it is. Oh, still not. 100 nanoseconds. What happened now? Mhm. Yeah, let's do that.
If that condition is right, it will come out from the beginning. It will end.
Yeah.
It should go.
Again, I think it should wait. Yeah, it should wait. Yeah, I think that's it. This should also wait for request to be one because acknowledgement not received within expected time. Yeah. Okay, we are getting the expected behavior. What is the expected behavior? If within 3 clock cycles acknowledgement is not received, we should get this thing displayed, right? So what we will do is we will make the stimulus generation a bit generalized. So I'll repeat maybe 5 times, begin, end, and I'll add a variable delay in delay, right? That delay will be a particular range, right? That will be going here, or number of clock cycles. Let's say number of clock cycles. Number of clock cycles. Num clock cycles, right? So at positive clock, request equal to 1, number of clock cycle equal to $u random range. Let's have it 0 to 5, 0 to 5, right? And then here we will have number of clock cycles. That many times this will wait and then give the acknowledgement. Now for that, if I want to repeat this 5 times, number of clock cycles can be maximum 5. So let's assume all 5 times I'm generating 5 clock cycles. So how many 25 clock cycles I have to wait for? So that will be 250. More than 250 time steps I should use to stop. Otherwise, before all 5 iterations are done, I will end the simulation. So 100 is not enough. Let's have it 250. Right? This is $finish logic. Okay, let's go for this. Let's see how many times which one gets displayed. We are outside of the fork and 25. What is happening? I didn't repeat. Yeah, see. No, this is happening only once. I'm not resetting those things. See, at next POSIX, if I'm repeating this, I need to reset the request and acknowledgement. YYP. You got the issue? Control V, replace 0. So now it will go down and work. But without, actually we are waiting here, right? Forever begin. Yeah. Forever begin. So this will happen. Yeah, you want to add. Yeah, okay, sure. Yeah, so that every time it is catching or not catching, we will get to know at what time it is catching. Dollar time. All right. Dollar time. So let's have this executed. Now we are stuck. We are ending simulation, right? At 25 we are stuck. Let's see. At 25 only we are stuck. Yeah, at every positive should happen. Yeah. So it's happening only for the first time and then not happening. Oh, it's not breaking yet. Break. Uh-huh. Yeah. Mhm. Yes, quit it. Yes, quit it, quit it. Not happening. End simulation. It's not stopping. Why did I add forever loop? I should have thought of that pause it first. Oh God, what should I do? It's not stopping at all. Array? Okay, let's do one thing. Just kill the session and start the session again. Yeah. What was the session ID? 15. So 20. Yeah. List none. Great. 15. I got 15 again. December, semaphore, multiple gems, and now we have request access. Yeah. GVim, disable, for product. Yeah, we have added the, see, this is waiting. Oh, this is not that one. Request acknowledgement. I was supposed to open request acknowledgement. Right? Yeah. So this was waiting without any pausage. So it was waiting forever. I mean, it was happening forever without any delay. So when we add pausage, it will wait only at pausage and then it will stay there. It won't be. Yeah. Yeah. So when you don't add pausage, this will get executed at 0 time. And it should actually stop here, but it's still going inside forever begin. What thing we have written in forever begin? Fork. Yeah, but it should have waited here, right? It should have waited here at line number 37 and line number 44. No, but then that will be single process. This one and this one won't be separate processes anymore.
It will continuously do and disable the post. It will happen. It won't come out from forever.
This, see, it will start at forever. It will start here. Then it will see this process. If this is same, it should wait here. If this is also not same, it should have waited here. But let's see. If this gets us into same situation, we'll try something else. Yeah, we have given. It should have finished, right? It doesn't go there. It gets stuck in the forever loop over here. Since we have not given any delay, let's hope that this. I mean, I think that was the issue. If this doesn't work, gets us into same situation, we'll think of some other logic. We'll try to catch what is the issue. What we'll do is we'll display where we are stuck. YY and T, so that we have some idea of what is happening inside forever. $. So if we are stuck here, we'll get to know that. Yeah, I'll have to source that all over again. I'm scared of running the code now. To run starting. What? It's, okay, good. Okay, it's finishing. So issue was either it was it. So let's have a look at vsync. Okay, that pause happened because of that previous simulation. Yeah, we need to remove these files. Yeah. So request is high, acknowledgement is high at the same time. Okay, request is high, acknowledgement is high. 1, 2, 3, 4. After 4, this is 1, 2, 3, 4. After 4, again 4. This is so none of them are caught, is it? Acknowledgement received before 3 clockages. Not received. Okay, at 25, the first one that we saw, that was exactly at the same time, at 0 time, with 0 repetition of pausages, we are getting the acknowledgement received. So this one at 25 nanoseconds, we are getting that one displayed within 3 clock edges. This one is not received. Received before. Let's look at 85. What is happening at 85? Okay, at pausage, it checked for here also we'll get it. Here also we'll get it. Why is acknowledge? I mean, request not going back low? Let's see. There is some issue in the way we are generating stimulus. It seems. Request is okay. When request is raised, we should at next pausage we should do this, and request acknowledgement. Both things should happen in separate initial blocks, I think. Okay, this is turning out to be a bit complicated now. Yeah, no, that's fine. Once we have done this, after one, okay, we are going to compulsorily consume 1 clock edge. That's fine. Let's do this. Oh, it's not removed. Yeah. Acknowledgement received before 3 clock edges. Not received, not received, not received. 4 times it's happening. So mostly what we are getting is, we are getting just a larger number of delay, not smaller numbers. So let's reduce the range. Instead of 5, let's make it 4. And instead of 0, let's make it 1. Yeah, couple of times we are receiving, couple of times we are not receiving. And let's have a look at waveform. Request is high, the next pause is low. Acknowledgement received within the required time. So this is where, no, 1, 2, 3. This is where we are not receiving. This is also where we are not receiving within 3 clock cycles. But this, yes, we are receiving within 3 clock. In 1 clock cycle, we are receiving basically. This also. You got it? Is it clear? Let's have a question now, question answer round here now. Did you understand why I have done this one? What is this? Stimulus generation. Why? Because I don't have a DFM in this code. I don't have a memory which will respond. There is no way I can, even if I had memory, there is no way I can have variable delay of receiving the ready signal, right? It has to be some specific delay, that is at the right position of the clock, correct? It can't be variable. I need to see what happens when different delays are there between request and acknowledgement. So that's why what we have done is we have generated a delay, number of clock cycles, right? So first we are starting the request, and then after a particular delay, we are raising the acknowledgement, and that delay is randomized. Number of clock cycles, that value I'm giving it is randomized. So I don't know which one is going to happen now, this one or this one. Now here in this implementation of join, what I have is one process which is wasting 3 clock cycles. At every pausage, it checks if request is raised. If it is not, it waits in line number 41. Okay. At every pausage, it checks if request is raised. If not, it stays there itself. Okay. The same thing happens in line number 46, 47. As soon as it sees request raised, right, it starts this. First process starts this. If acknowledgement comes before 3 clock edges, before 1 or 2 clock edges or 0 clock edges, if acknowledgement comes before these 3 clock edges, what will happen? This will never complete. Because then it's waiting at this point, it will receive this and display this, come out of the joining and disable the code. This will never happen. This line will never complete. Correct? Are you getting this? If we get acknowledgement, if we don't get acknowledgement, what will happen? We'll be stuck at this line here in the second process. This thing, I mean, this process will not end. But if this happens first, right? If acknowledgement is received after 3 clock edges or at 3 clock edges, this will happen first. This will display and first process will end. As soon as first process is ended, we come out of the join any and we disable the code. So this process will never end. Clear? So this is the, what can we say? This is the assertion check replacement. If this logic we are able to integrate with our memory test bench, we don't have to write the assertion. But as you have seen, this logic, this much only, it's a bit complicated. And to integrate, when we integrate it with our test bench, that won't be that much complicated because this is exactly what we'll have to do. At every pausage, we'll have to check. Assertions also work the same way. At every pausage, they check if request is raised, then they'll look for acknowledgement. That's what they do. So if you literally copy this block as it is from here and integrate with your signals in memory test bench, this will work all fine. And since in memory test bench, after every pausage of the clock, whenever valid is raised, next pausage we are getting ready, this will never happen. That's how we have written our functionality. This will never happen. Only this will happen. Right? But in some project, there is a possibility that acknowledgement can be received after 3 pausages as well, which is not desirable functionality. There it will catch that error. Is it clear? Are you clear about this particular code, everyone? Are you clear about this particular logic? Understood? Understood?
Explain stimulus generator, ma'am.
Yeah. Stimulus generation, this one?
Yes, ma'am.
Yeah, so previously I had a simpler stimulus generation. What I was doing, I was raising request, it was raised entire duration, and as soon as I'm receiving acknowledgement, I was coming out of this fourth join, right? So when I repeat the number of stimulus, what happens is I need to make sure that every pausage, not every pausage, at a pausage only, I need to raise request, and next pausage I need to put it down also, because if it stays raised, what happens is for even when acknowledgement is not received for that particular request, right? At the end of the clock, it reads as acknowledgement received in 0 timestamp. Do you remember that one? What was happening? This was request, right? We consumed like 3-4 clock edges here. right? And at the last clock edge, we are getting acknowledgement. So for this, this portion it says that acknowledgement not received, but for this portion it says acknowledgement received. But it's faulty operation, right? We need to check if this acknowledgement is received with respect to this stimulus. So that's why we don't want request staying high entire duration. So what we did, we raised the request, and at next posage we dropped it, right? So now corresponding to this one posage of the request, one entire posage of the request, I should look for what is the number of clock cycles that are consumed to receive acknowledgement. Receive acknowledgement, right? So this is request generation. Now next part is acknowledgement generation. Since we don't have a DUT which is going to respond to us, it's us in this particular example, we'll have to generate this particular stimulus. So what I'm doing is this repeat of number of clock cycles I'm doing, and that number of clock cycles value I'm generating randomly, right? So after random number of clock cycles, I will raise the acknowledgement. So I'm also giving the range here 1 to 4. So what will happen here? Either any number from 1 to 4 will be generated. Take an example, 2 is generated. So this will be 2 number of clock cycles, right? So it will wait for 2 posages of the clock and then raise the acknowledgement, which is expected functionality. After request is raised, I'm getting the acknowledgement within required number of posages. So we will be in this particular scenario. If it is 3 or 4, it doesn't satisfy, right? This will stay in wasting of the time, and then after that it will raise acknowledgement for 4 or 3 clockages. That means that within required number of clockages, I did not receive acknowledgement. So in that case, this portion will get executed. Clear? Stimulus generation clear?
Yes, ma'am. Yes, ma'am.
Yeah. Anyone else having any other questions?
Ma'am, can you once open the waveform?
Waveform, yeah.
Here it is we consider the posage that after ending the zero or repeating the delay.
I
we use
didn't
the
understand.
number of clock cycles we use in, ma'am. Repeat number of clock cycles.
Yeah, 3. It's
Yeah,
3 here,
but
right?
how it will consider as a 0, 1, 2, 3 that clock cycles?
Yeah.
Can
So
you
this is I have raised the request here. So this is 0.
Okay, ma'am.
No, yeah, this is 0. Where I have raised the request, that is 0. That is not considered. Then we have 1, 2,
Okay.
3. So after 3 clockages, we are raising the acknowledgement. So this is we're not receiving in enough time.
Yes,
Expected number of clock cycles. So we are getting into that first scenario. Acknowledgement not received within
Not
expected
received.
number of time. Yeah, here we have 1. So we have raised request here. So
Yes, ma'am.
this clock cycle is not going to get counted. This one will get counted. After 1 clock cycle,
One.
I'm raising acknowledgement. So
Okay.
within 1 clock cycle, I'm getting the acknowledgement in the
So second case will be activated. Okay.
second case will be, yeah. So if this number was anything else, we would have seen that functionality. Maybe if we repeat it more number of times here,
Yes,
and
yes, ma'am.
increase the ending simulation time here, we will be able to see more variations.
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
Yeah. Any other question? Okay. So we'll go back to the PPT. So we come to disable force. Now the way we have seen disable force, if I want to disable force from inside the force, it has to be labeled. Now let's go over here. We can have, yeah, one more, what can we say, use of labeling force here is if we nest our force. It's a possibility that in your test bench you might require nesting the force. So what is nesting? Force inside that I'm writing another force. Now let's look at the same example that is given here. There is a top force, there is a low force. So this and this will start the functionality together. And let me use different color here. This and this will start functionality at the same time actually, because there is no delay consumed here anywhere between. So all these 4 things will start at the same time, right? Now what we have here is there is no disable union. Disable is given. This is join any functionality, right? Top dot low force. This force is disabled when it comes out of this join any, outer join any. So let me, yeah. So whenever either this or this, whichever one ends first, will decide if low force will be disabled or not. Okay. If this ends first, that is this one, the first one, then low force will be ended, which has no meaning, right? If this is ending, that means this entire functionality is complete. But if this ends first, then the other thing won't happen. If this ends first, both things will happen. If this ends first, then other thing, that is low force, will not happen. Did you understand what I said? If you didn't, observe the code and try to understand. See, I will mark these. If this ends first, that means I've come out of this join any after ending this, right? So this force disabling doesn't have any meaning, but it is disabling all the force. I didn't see that last line. After this will be disabled. So this won't function. So if this happens first, this won't go through. If this happens first, you are supposed to disable this. That will happen. And disable force, there's no point because that one is already done. Got it? So again, this is the same functionality we implemented right now with a different logic. Right? But this is nested code. So if I execute one particular logic, the other should be disabled. Are you clear about this code? Clear?
Yes, ma'am.
So you won't be able to disable a particular force. This line won't be possible if you don't label it. This won't be possible. If you don't label it, you won't be able to disable the specific one.
Ma'am, like we are disabling, we can write disable low force that will will be executed, no?
No,
So
because low force, low force is inside top force.
So we should label
So
and we
you
should
have
call
to,
it.
yeah, correct.
Okay.
Clear? He was asking if we can directly give disable low force. But low force it will give you error saying there is no label called low force because it is under this particular scope, top force scope. Okay, can someone try and tell me what is wrong with this piece of code? Yeah,
Because of
remove
yeah,
answers.
yes, ma'am.
Yeah, tell me.
because of join none, if any process is not ended also, it will come to next line. So disable fork will be
Correct.
ended before the
Yes,
process starting.
correct. Yeah. So tell me, what is problem with this code? Where is the answer? I don't know. What is the problem with this code? Yeah. No use of fork. Why? Because we are writing begin and inside the fork. So that means all three processes will execute sequentially. If my intention is to make them run concurrently, P1, P2, P3, it's not getting fulfilled, right? Yeah. So I was okay. Yeah, I was hoping we could complete a few more topics today. Do you want me to continue or you want me to stop here? Continue? Okay. So the next topic, actually there are a couple of topics, program block and scheduling semantics. So these two topics are not that important with respect to fresher perspective. So what I'm going to do is I'm going to skip these, but when Srinivas resumes the course, he will cover these. Okay. No, it is not related. No, it's not related. Scheduling semantics is for people who are working on coming up with new tools. The way we have QuestSim, right? Scheduling semantics is for them to understand. For verification engineers, it's of no use. And program block depends on some concepts from scheduling semantics. So the topic is not going to be skipped. When sir resumes the sessions, he will cover those. I have informed him that I'm not covering these two topics. He said I will cover them when I will rejoin. Okay. So we will skip this for a while and we will start working on next important topic from interview perspective, which is tasks and functions. So we have been using tasks and functions in System Verilog, but we didn't formally saw what all the differences are there. Okay. So first difference, can someone tell me what was the first difference? Task and add? Yeah, no, not from task and function. Tasks in Verilog and tasks in System Verilog. Similarly, tasks in functions in Verilog and functions in System Verilog. In task, there is no difference. Okay. Mhm. You have done that as a reference? Okay. So, okay, then what is not done? Oh, okay. Okay, so let's go to this one. So, differences from Verilog. So, in Verilog, what is the first thing that we have in Verilog? Can tasks define output arguments in Verilog? Can functions define output arguments? No. So, in Verilog, functions do not define output arguments. In SV, functions can define output argument. Now, related to this is another difference. Let's see. Hash one. Yeah, another difference that is by default values and by default. In Verilog, we cannot provide default values of input arguments. Can we provide default values of input arguments in System Verilog? Does it depend whether or not I define direction of the arguments? Yes. Yeah. And that can be in any order. I can define couple of arguments without any direction, then an output argument, then another argument without argument. It will still read it as valid arguments, right? And for whichever arguments I'm not providing direction, it will be by default taken as input argument. Does it happen in Verilog? No, you have to specifically define that. In Verilog, we specifically define direction of the argument. In System Verilog, if we do not specifically define direction of the arguments, it is taken as input. Okay, what will happen if I define, what will be the output of following code? Let me know, okay? I have function in add, okay? Input A, input B, and function. Then I have return A plus B, right? I provide A equal to 10, B equal to 10. What will be the output? Yeah. While calling, if I don't pass any argument, it is supposed to return 20. But I have not defined any data type here. So default data type is bit. So it will return 0. Why? Because 20 is an even number. LSB of even number is 0. If I pass 11 here, output will be 1. Because LSB of odd number is 1. So what is important here? Along with direction, data type. Right? And this actually is the answer of a lot of students in mock interviews when I ask them to write simple function to add two numbers. And they try providing larger values and say, I don't know why this is not working. Because you didn't provide data type. Okay? So this is something you need to keep in mind while writing any tasks or any functions, that data type is important. Because by default it takes bit. Okay? Output of above function will be in bit format if we do not mention any data type. By default, bit is the data type. Clear? Reg. Yeah. So what you can do is to check that try providing access and here keep integer. If it returns XS, then you know, because if this is bit, even though the return type is integer, it will still provide 0. So I have not tried that one. You can check this. Okay. In lab timings, you can check this one. Okay. Okay. Yeah. Cross check if bit or reg during lab. Okay. So let's see what else. Beginning, right? Hash4 in Verilog, we write multiple number of lines of tasks or functions within begin end. In system Verilog, begin end not required. Okay. What else? Without argument also that can. What we will do is, yeah, we'll name it. In Verilog, we need minimum one argument for a function or task also actually. Yeah, check for the task, but I think for both you require minimum one argument. In system Verilog, without argument, we can have a task or a function. Correct? Yeah, in Verilog, we don't have a concept of return. In Verilog, we don't have a concept of return, right? Any value that function returns needs to be done by on the name of the function, right? And task cannot return anything. Here also task cannot return anything, but task can return. I'll tell you what is the difference. Yeah, since there is no concept of return anyway, that cannot happen. We can return a value from function, or we can return from a task or a function. Return from a task or function. So what is happening here is, let's look at this example. So task, let's do it as a task. Task run and task. Okay. So what we have here is this much. So there is some functionality. Process 1 doing something, calculating value or comparing. Oh no, just calculating val 1, right? There is process 2 calculating val 2. There is process 3 comparing val 1 and val 2. If compare pass, I need to return. Else, I need to do rest of the functionality. So I'll explain. What is happening here is there is some calculation happening. This is probably what we will require the return for. Okay, some calculation is happening here, some calculation is happening here, right? And these calculations are being compared. So if compare pass, I need to return from the task, meaning none of the functionality below that return should execute. I don't want to do rest of the functionality. Else, I will do rest of the functionality. This is possible. Now, how we can have a look at this is we can simply do some display code. Let's see, function, task, function, .sv, module talk, and module, right? Task, run, and task. I'm not going to compare anything. I'm just going to return. So I have, let's see, $display. Since this is task, I will consume that. #1 $display %t display 1, comma $time y 2p. Now here at the end, I'm returning display 2, display 3. So out of this, when I call run method, 1 and 2 will happen, 3 won't happen. Okay, initial, begin, and run. Got it? It's not going to last one. So if I change, yeah, if I add one more here, y3, display 4, and double T this from here and paste it here, now I will get 3 displays. 1, 2, 3 displays. Okay, we're getting all 3 displays, but fourth one is not happening. So whatever I write after return is not working. So this doesn't have any meaning. If I just write return and then some code, it has no meaning. So in practical uses, return is done if some condition is passing, else we continue the code. Okay. No, it's not returning. Task won't return. It will return from the function. It will stop functionality of the function. So otherwise there is some functionality here, right? Yeah, that won't execute. Okay. So this is added here. And you know how rest of the functionalities of return are. It can return the value, whatever you are calculating or operating on or modifying in the function. Correct? So what else? Hash 7. Yeah, pass by value, pass by reference. You know how to work on it? Okay. So I'll give you a code example. Tell me if it is correct or not, or if it will function properly or not. Okay. So hash 1 in Verilog, pass by reference concept is not there. In system Verilog, pass by reference is added. What this means is you do not pass the copy of the argument. You directly pass the handle of the argument. I will explain how that works and then you tell me, okay? So what we have is when we create a function, we ask for argument, right? So whatever argument we pass here in the function, it is stored in the particular memory. It will be used inside the scope of that function, right? So when we pass by value, this is the argument outside, right? It is stored in some other memory, value 1, and it is passed inside, it is called as A. So two different memories are created. This is passed by value. You are passing the value. Whatever modification I make here in this function on A won't reflect on val1, okay? But when I pass by reference, I have a val1 created in this particular, allocated this memory. So the argument that we pass is reference of this memory, meaning that is handle of this memory, meaning there won't be different memory created, the same memory handle will be passed, meaning whatever modifications I do in the scope of the function here, right, whatever modifications, they reflect exactly here, because I'm not doing in a new memory, I'm doing in the memory that was previously created. That is passed by reference. Clear? So if I write something like this, let's say function add or increment, right, it is accepting int A and function, and when I'm calling it, okay, A plus plus, I will not display it here, I'll display it here. So when I'm calling it, initial, beginning, I am CR and I'm passing A here, where A is int A. Okay, I'm making A equal to 5, and I will display $display A equal to %0D, comma A. Right now, what should be the display here? 5, right? So let's execute this. I will comment this part. I don't want this displayed. Oh, okay. I have line number 58 to 67. That is 10YY. Fine, right? So now what I will do is I'm passing reference of, yeah. I'm not sure about the order, but let's see. Uh-huh. Okay. Okay. Function automatic. Automatic order is first function, then automatic, right? What is happening here? Now you need to understand the significance here. I'm not returning anything, right? And I'm displaying outside. I'm displaying in this scope, right? If I display this inside and it displays 6, then fine, right? Because this value is not being returned. This value is simply being modified inside. So if I pass by reference, modification will happen in this particular value, which I'm passing here as an argument, right? If I pass by value, modification won't happen there. Clear? So let's see, this particular concept is there. Let's see, let me write this much. Copy, paste here. A displays 5. The same thing here. A displays 6. Okay, this is one more difference. What else is the difference? Yeah, there is continue and break, but it's not part of task and function alone. It can be part of any procedural block. Okay, so I won't write it as a difference. I'll just write it as a separate topic, continue and break. So it can also be used in for loop. So let's say continue and break.sp. So module talk and module. See, now to understand the concept here is a very small thing, right? Because continue and break or pass by reference, right? These things you will not see in your immediate projects, or you will not see in industry level project as well, right? These are the concepts to understand. You should know what is possible, because in some project you see this continue happening. You should know what is the functionality of continue. What happens if I write continue? You should know what is the functionality of break. What happens if I write break? Or what happens if I write return in the middle of the task? Now I have seen return or continue or break in UVM source code. When I want to understand how a particular method, pre-written method in UVM is working, I'm referring to UVM source code, and there I find it. So you got the usage of these concepts. That will be somewhere where you're developing a particular methodology, right? So not in, it will be used in project. That particular same function will be used in project, but you won't be directly using it. You might be reading some source code to understand how it is happening, how it is functioning. So you should know the functionality, but don't break your head a lot behind this. Go through this, understand, and move forward. There are more important concepts coming up. Okay, so let's see initial, begin, and what I can do is a for loop for int I equal to 0, I less than 5, I plus plus. Begin. End. So if I'm going to write really simple code, if I equal to 1, I equal to 2, I want to continue. Else, I want to modify some value. Print A. A equal to 10. Else, if I is not equal to 2, I'm making change in A equal to 20. Right? Not 20. A plus 20. A plus 2. Let's do that. And instead of just continuing, I'll display also. Yeah. Begin. And dollar display I equal to percent DOD, comma A equal to percent DOD, comma I, comma E. So what will happen here is, if I becomes equal to 2, the code will continue, meaning whatever is written after continue will not execute. This entire code won't execute. It will simply go and increment the loop variable, right? So when I equal to 0, will continue happen? No, it will go in else part. It will increment A by 2. It will display. Then again, this is ending. Then I equal to 1. Again, continue won't happen, right? What will be then executed? This again. Again, A will be incremented by another 2 value. Then this will be displayed. Then loop variable will increment. Now loop variable is 2. It will satisfy this condition. And then I'm continuing, meaning if I equal to 2 is seen, I don't want to do rest of the operation, but I do want to increment and stay in the same loop, right? So can you think of any scenario where you might need to continue the loop without doing any functionality, rest of the functionality? Or I can do some functionality here, right? It doesn't have to be just continue, right? I can write some functionality here, like updating some value, updating something, right? It doesn't just have to continue, right? Are you getting this? Before continue, I can write anything. If this condition is satisfied, I do something and then continue, but I don't do next part of the code. Or whatever I have written here, I can dollar display here as well. The same thing. I equal to percent 0D. This display also won't happen. A equal to percent 0D, comma I, comma A. This display will not happen, right? Not just else part, even this display won't happen if this is seen. It will only do this part of the code, whatever you have written, and increment the loop variable. You can try implementing this logic in your code for filling up array without repetition from Verilog. Do you remember that code? Or do you have that code? You can modify it for system Verilog purpose, system Verilog way of coding. Right? Continuing, there is a case where you want to simply increment after updating the array. You want to increment. You don't want to do rest of the functionality. But there is a condition under which you want to do the functionality. Right? So try working this particular concept in that. Or if I write break here, it will break out of the for loop. So I'll do this functionality without break first, and then with break. Now else part, at first iteration only it will break. So that's fine. Let's see what happens. Okay. Continue break run one dot do. Did you understand functionality of continue and break? Continue will continue the loop variable iteration, next iteration, without doing rest of the part of the coding, right? And break will break out of the loop. Okay. So CONT BRK dot SV. Line number 6. I think I need to do double equal to here. Right? It's conditional, right? I equal to 0, I equal to 1, I equal to 3, I equal to 4. For I equal to 2, it's not incrementing 8. Got it? It just continued the next iteration. Now, what if, what I can do is, I can just break out of here. Here itself. So it will exit the loop. As soon as it has seen 2, I equal to 2, it's exiting the loop. What also I can do here is, y by p, right? And keep continue and then break. Let's see what happens here. What do you think will happen here? Break didn't happen. I wrote continue, right? As soon as I uncommented continue, rest of the code, what is written after continue, won't execute. Clear? Understood the functionality of these two? So we can stop here because next topic is basically this thing, constraints and randomization. But job for you is to go through slide PPT of tasks and functions. If we have missed something, I'll cover in next session. Okay? If we have not missed anything, I think there is system tasks. We'll do that in a few minutes in constraint randomization. Before starting that, we'll do system tasks and function. Most of them are from Verilog. Okay, please go through the PPT slides of tasks and functions. We will cover system tasks in few minutes in next session. Any doubts in today's session? Any doubts? Online? Okay. So we'll stop here. Tell me. Hello?
No, ma'am, no doubts. That's what I'm saying.
Oh, okay. No, okay. No worries. Okay.